Determining the correct wire size for a well pump installation is paramount to ensure safe and efficient operation. The goal is to select a wire gauge that can handle the pump's current draw over the specified distance without excessive voltage drop. The calculation provided uses the formula circular mils equals 2 times K times I times D divided by volts dropped, where K is a constant representing the wire material, I is the current in amps, D is the distance in feet, and volts dropped is the allowable voltage drop. In this scenario, aluminum wire is considered where K equals 21.2. The current I is specified as 28 amps based on table 430.148 of the National Electrical Code, or NEC, which provides full load currents for motors. The distance, D, is 500 feet. The allowable voltage drop is calculated as 240 volts multiplied by 0.3, resulting in 7.2 volts. This assumes a 3% voltage drop limitation, which is a common guideline. Plugging these values into the formula yields circular mils equals 2 times 21.2 times 28 times 500 divided by 7.2, which equals 824,442 circular mils. This circular mil value then needs to be converted to an American wire gauge, or AUG, size. The calculated circular mil value of 824,442 corresponds to a very large wire size. AWG sizes are inversely proportional to their circular mil values. Common wire sizes for direct burial 3-wire systems include 2 AWG and 1/0 AWG. Given the calculation results, 1/0 AWG is the appropriate selection. It is crucial to understand why using smaller wire sizes such as 12 AWG or 10 AWG as suggested is inappropriate and potentially dangerous. Firstly, the ampacity of 12 AWG and 10 AWG wire is significantly lower than the required current carrying capacity for a 5 horsepower or HP well pump. Secondly, using undersized wire leads to excessive voltage drop. Voltage drop occurs when the voltage at the load, in this case the well pump, is lower than the voltage at the source due to the wire's resistance. Excessive voltage drop can cause the motor to overheat, operate inefficiently, and potentially fail prematurely. Thirdly, undersized wires can overheat, posing a fire hazard. When a wire carries more current than it is rated for, the wire's temperature increases. This heat can melt the wire's insulation, creating a short circuit or ground fault, which can lead to a fire. NEC Table 310.15/16 provides ampacity ratings for various wire sizes and insulation types. It is imperative to consult this table to ensure that the selected wire size has sufficient ampacity for the application. In addition to ampacity, voltage drop is another critical factor to consider. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. Voltage drop can be calculated using various formulas and online calculators. The formula provided is a common method for estimating voltage drop. The selection of 1/0 AWG wire is based on the calculation and the need to minimize voltage drop and ensure adequate ampacity. Factors to consider when selecting wire include the wire material, the insulation type, the ambient temperature, and the installation method. Aluminum wire is less conductive than copper wire, so it requires a larger gauge to carry the same amount of current. The insulation type affects the wire's temperature rating and its ability to withstand environmental conditions. The ambient temperature affects the wire's ampacity rating. The installation method affects the wire's ability to dissipate heat. The NEC provides specific requirements for wiring in wet locations, such as well pump installations. These requirements include using waterproof connectors and ensuring that the wire is protected from physical damage. Grounding is also essential for well pump installations. A grounding conductor provides a path for fault current to flow back to the source, which helps to protect against electric shock. The NEC requires that all electrical equipment be properly grounded. It is crucial to consult with a qualified electrician to ensure that the well pump installation complies with all applicable codes and standards. An electrician can perform a load calculation to determine the exact current requirements of the pump and select the appropriate wire size. They can also ensure that the wiring is installed safely and correctly. Ignoring these calculations and recommendations can lead to significant problems. Using undersized wire, as suggested, would create a dangerous situation with a high risk of motor failure, fire, and electric shock. Always prioritize safety and adherence to electrical codes when performing any electrical work. Furthermore, consider the long-term implications of choosing the correct wire size. While the initial cost of larger wire may be higher, it can save money in the long run by reducing energy consumption, preventing equipment failure, and improving the overall reliability of the electrical system. Proper wire sizing also contributes to the longevity of the well pump motor. By minimizing voltage drop, the motor operates at its designed voltage, which reduces stress and heat, extending its lifespan. In contrast, operating a motor with insufficient voltage can significantly shorten its lifespan. The NEC provides detailed guidance on motor wiring and protection. Article 430 of the NEC covers motors, motor circuits, and motor controllers. It specifies the requirements for motor overcurrent protection, motor overload protection, and motor disconnecting means. It is important to understand and comply with these requirements to ensure the safe and reliable operation of the well pump motor. In summary, the correct wire size for a 5 HP well pump located 500 feet from the power source is 1/0 AWG aluminum wire. This selection is based on a voltage drop calculation, ampacity requirements, and consideration of safety and code compliance. Avoid using undersized wire, as it can lead to serious consequences. Always consult with a qualified electrician to ensure that the well pump installation is performed safely and correctly. 21.2 value used for K is an approximation for aluminum. It is important to verify the specific K value for the type of aluminum conductor being used from manufacturer data. The 28 amp value from table 430.148 is a full load current. It does not account for starting current, which can be significantly higher. Motor starting current can be several times the full load current. This inrush of current can cause a temporary voltage drop, which can affect other equipment in the same circuit. To mitigate the effects of motor starting current, it may be necessary to use a larger wire size or a motor starter with reduced voltage starting. Reduced voltage starting methods, such as auto transformer starting or part winding starting, reduce the inrush current during motor starting. The type of insulation used in the wire also affects its ampacity. Common insulation types include THHN, THWN, and XHHW. Each insulation type has a different temperature rating, which affects the amount of current the wire can carry safely. It is important to select an insulation type that is suitable for the ambient temperature and the application. The installation method also affects the wire's ampacity. Wires installed in conduit have a lower ampacity than wires installed in free air. This is because wires in conduit are not able to dissipate heat as effectively as wires in free air. The NEC provides ampacity correction factors for various installation methods. These correction factors must be applied to the wire's ampacity rating to determine the allowable current carrying capacity. For direct burial applications, the wire must be suitable for direct burial and must be protected from physical damage. Direct burial cable typically has a rugged outer jacket that protects the conductors from moisture and abrasion. The depth of burial is also important. The NEC specifies the minimum burial depth for various types of wiring. Grounding is a critical safety measure for well pump installations. The grounding conductor provides a path for fault current to flow back to the source, which helps to protect against electric shock. The grounding conductor must be sized according to the NEC and must be properly connected to the grounding electrode system. The grounding electrode system typically consists of a ground rod or metal water pipe that is buried in the earth. The well casing itself should also be bonded to the grounding electrode system. Bonding is the process of connecting metal parts together to create a continuous electrical path. Bonding helps to prevent voltage differences between metal parts, which can reduce the risk of electric shock. Surge protection is another important consideration for well pump installations. Power surges can damage electronic equipment, including well pump motors and controllers. Surge protection devices, or SPDs, can protect against power surges by diverting excess voltage to ground. SPD should be installed at the service entrance and at the well pump controller. Regular maintenance is essential for well pumped systems. This includes inspecting the wiring, connections, and grounding system for signs of damage or corrosion. Any damaged or corroded component should be replaced immediately. The well pump motor should also be inspected and lubricated regularly. A qualified electrician should perform these maintenance tasks. Safety is always the top priority when working with electricity. Always disconnect power before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, hire a qualified electrician. In addition to the NEC, local codes and regulations may also apply to well pump installations. It is important to check with the local authorities to determine the applicable requirements. Obtaining the necessary permits and inspections is also essential. Permits and inspections ensure that the installation meets the applicable codes and standards. They also provide a record of the work that was performed, which can be helpful in the future. In conclusion, selecting the correct wire size for a well pump is a critical task that requires careful consideration of various factors. These factors include the pump's current draw, the distance from the power source, the allowable voltage drop, the wire material, the insulation type, the installation method, and the applicable codes and standards. Always consult with a qualified electrician to ensure that the installation is performed safely and correctly.